All right, welcome to Intermediate Algebra Exam 3 review. Just to remind you, as usual, that this is in our online math resource course. So once this recording is finished, we have reviewed. If you go into Intermediate Algebra, inside here, test review materials. And you're going to click on My Math Lab review because we are My Math Lab. And here we are. This is the version we are working on today. We are working on version B. We are working on the solution guide right now. And the video will be posted once Zoom compiles it and we get the link from Zoom. So right here is our exam 3 review. If you haven't downloaded it or you want to follow along, please feel free to click and download the review that we're going to work on. And with that being said, let's get to this exam 3 review. So this is going to cover rational functions and radical functions. So those two big sections there, and there are 20 questions just like all the other exams. So let's start with rationals. How do we find the domain of rationals? So we got this rational function, f of x equal to 5x all over 4x minus 8. How do we find the domain?
You need to get x by itself.
Okay, which x?
The bottom one.
The bottom one. All right, so let me jump over to
So we
my.
equal it to 0, right?
That's right. When you want to find the domain, you're going to take the denominator and equal it to 0. So we're going to take 4x minus 8 equal to 0. And we're going to do what Shami said, and we're going to solve for x. All right. So how do I get x by itself?
And move the 8 to the side.
Okay, so we'll add 8, add 8. 4x is equal to 8. Then what?
Divide.
Yeah, divide by 4. Divide by 4. X is equal to
2.
2. Perfect. So remember that there were two ways to write this. We could write this as a set, or we could write this in interval. So the set one is really what they want out here. They're giving you the set answer. And since you found an answer for x, you're going to be selecting A, and all you got to do is put the number 2 in there. Okay, so select A, slap in the number 2, because we actually found an answer. So if you remember from my videos though, if you have me, that set notation, you put your squiggles, you tell us the variable that was used, put the line, and then remember, this is the person that we do not like, which is why we put x equals 2, but the equal sign has a slash through it. In my videos, I compared that to the drunk friend that you don't want to bring to the party because you don't want to babysit. So this is the drunk friend we do not want to invite to the party. We'll take everybody else but 2. And if we did interval notation, I related that back to what we did in compound inequalities. This looks like an OR answer. So again, as I said, this is the only person we do not want to invite to the party. So that means we're going to invite everybody starting from negative infinity, and we're going to move up to 2. And we're going to be like, hey, 2, how you doing? Oh, that's cool. And we're going to jump over it. This is what I called the jump notation, because we don't like 2. We're going to jump over it. And then we're going to continue inviting, hey, there's a party this weekend. Hey, there's a party this weekend. Hey, there's a party this weekend. And there we go. This is really the notation they're after, but it's good to review the interval notation because when you go to college algebra and things like that, we like interval notation a lot. Any questions about number 1? Okay.
No.
Number 2 is just like this guy. You're going to do another domain. So here we've got f of x equal to -5 minus 7x all over x cubed plus 8x squared plus 7x. We want to find the domain. So how do we do that again?
Set the bottom to 0.
Set the denominator equal to 0. All right. So we got x cubed plus 8x squared plus 7x. Again, for rationals, it's all about what the denominator is telling us. We don't care about the numerator. The numerator can do whatever it wants. It's the denominator that's the key. So what are we going to do with this now?
Wouldn't you combine like terms? Or
There are,
get x by itself? I'm sorry.
we do want to get x by itself. I agree. But there are no like terms to combine. This is
factor?
x. Yeah, there we go. We got to factor this thing. We can't do anything until we factor. So what's the first thing we're going to do with here?
Well, we can factor with your head. You have to do the AB thing that you showed us.
Okay, so like the AC method, all right. But
But
before we can apply AC, what's the first line of defense in factoring?
should we take out, what do you say? You take out, you see if they have, like if they have all variables.
A common variable.
There we go.
Yeah.
Yeah, that GCF. Do these all have something in common?
A common.
Yes.
You have the X.
They all have an X. And the most amount of X's we can pull out is 1. And that will leave us with, well, there were 3 X's. I took 1 out. X squared. Plus 8, there were 2 X's. I took 1 out. 1 left. And then add the plus 7. There was 1 X. I took 1 out. Nothing left. And then now you got to factor this guy. But I'm not going to show the factoring work because we are beyond that. So I need to know, what does that part factor to?
X plus 7, X plus 1.
You got it. X plus 7 and X plus 1. So there is our denominator factored. So if I want to get X by itself, like what Shami said, remember we have that thing called the zero product rule. And the zero product rule says that if you have 2 variables that are being multiplied and they equal 0, then either A is 0 or the B equals 0. So what we have right here is we got 3 things that are multiplying and they equal 0. So that zero product rule says we take each one of these factors, that one, my X plus 7, my X plus 1, and we set them all equal to 0. Because this is like A times B times C equal to 0. One of these has to be 0. Or maybe all of them are 0. So do we get to solve anything here?
Well, the first
No.
one's already set to
Yeah,
0.
the first one's ready to go. X equals 0. It's good to go. So what are we gonna do for the next one?
They're not invited.
Okay, but how do we figure out who's not invited? We gotta get X by itself.
So -7.
Uh-huh. Gotta do a little bit of solving. So X is equal to -7. So we don't like 0, and we don't like -7. What do we do for the last one?
-1.
Yeah. And we don't like -1. So out here, you're just gonna put -7, comma, because it says separate with commas, -1, comma, 0, because that's the set answer. So just -7, comma, -1, comma, 0. Because the set answer is just listing who we don't like. So squiggles, X bar, X does not equal -7, -1, and 0. These are the numbers we are not inviting. Does that make sense?
Yes.
Okay. Interval, just to talk about that real quick. Again, we're gonna invite everybody at the college, but -7, -1, and 0. Everybody's coming but those three, because we don't want to babysit them. So we start at -infinity. And who do we go up to first? Who's the first one we're gonna jump over?
-7.
Yeah, -7. So we're gonna be like, hold on one second. Hey, -7, how's it going? Oh, did you take that philosophy exam the other day? Cool. And we jump over it. And then who do we jump over?
-1.
Yeah, right. Like, hey, -1, long time no see. Did you see that soccer game last night? Yeah, cool. Then who do we jump over?
0.
Yeah, Chanice, you're on fire. And then we're like, hey, 0, let's catch up on a game of Monopoly later on. And then from 0, we move on to infinity. And that is what the interval answer looks like. And remember that these are unions. Whenever you use a union, please make sure that you use the MyMathLab union symbol and not a capital U. If you have to use it, I'm just saying if. Okay, those are union symbols. Any questions about 1 and 2 over domain? Take that denominator, set it equal to 0, solve. Question 3. Here we go. All right, we want to simplify. How do we simplify? Gosh, I cannot write this morning. How do we simplify?
We have to factor it, the top one.
Absolutely. We got to do some factoring. Factoring is big with rationals. Once it's factored, then we can look and see if we can get rid of people or families, things like that. So 3 and 4 is all about simplifying. All right, so the question is, how does this numerator factor? If it does, maybe it does, maybe it doesn't. I don't know. And then how does the denominator factor? Because there are no GCFs in these. I know our book likes GCFs, but unfortunately for these, there are no GCFs. So how does that
Don't we have to do like put in the top one? When we have to do like put in the 3 to the 16?
You might have to do an AC or a guess and check or a box method or slide and divide. It's your call, but I'm not showing that work. Because we are beyond factoring now and I need you to be able to perform it.
Almost finished.
No worries.
Slow.
I am very patient with this, providing that wait time, because I know factoring can be tricky sometimes.
It's 12 and 4, but I gotta figure out which one's negative, which one's positive.
No worries. And I'll take either the top or the bottom. If you got the bottom factored, I can write that in too.
Mr. Armstrong, I think I factored wrong. Because the
Okay,
top part I got 3 plus 4 minus
hold on. I like that. So it should be 3x plus 4. And then what's the next part?
x minus 4.
That is correct.
Oh, I'm like, why that looks weird? Okay, I gotta do the bottom.
So there's your numerator, 3x plus 4, x minus 4. Numerator was the tough one. The bottom one should be a little bit faster.
Yeah, the bottom one was faster. So I got for the bottom one is x plus 3 in parentheses and x minus 4.
Alright, that's a little off
Okay.
because, and it's really on the 3. Because a positive times a negative is negative.
Ah, I forgot my sign.
So on the 3, it really should be a what?
3 should be, let me
A
go back.
minus.
Yep,
Yeah. Because a negative times a negative is a positive, which
is a
matches that.
positive.
And then a negative 3 and a negative 4 is a negative 7. Alright,
Yes.
so there we go. Now we're factored. So is anybody going to cancel out? Anybody going to go away?
Yes.
Who?
x4, x minus
Yeah.
4.
Those guys are going away because I can cancel the whole family out. And we are left with 3x plus 4 for the numerator and x minus 3 for your denominator. And there you go. Any questions about number 3? Nice job, Jimmy's.
Thank you. I got to remember my signs. That's always mess up.
That's okay. So number 4, very, very similar. We're gonna do some reducing again. This time we have x squared minus 4 in the numerator. And we have 2
That is the
minus,
one I got confused with earlier that I said factored only the top.
what's
Like,
that?
because the bottom is already factored. Because I looked
Oh,
at that one. I didn't look at number 3. I looked,
okay.
yeah.
No worries. So this one definitely much easier than number 3.
I think it's x2, like x minus 2, x plus 2.
Yeah, good job, because that's a difference of squares right there. So that's an x minus 2, x plus 2. All over what? What's the bottom look like?
But it already has. Like,
What we already have. All right, so let's take a look at this. Does anybody cancel? Remember, it has to
You have,
match 100%.
so you have to, in order for it to match, you would time it by the denominator by -1.
Yeah, these two almost match. Problem is that this is a positive x, this is a negative x. It's a -2, that's a positive. The signs are flipped. Remember it when I told you in class that if you're almost matching, we could easily fix this by what Chamise said, multiply it by a -1. Or in other words, what's really going on is you're going to pull out a GCF of a -1. And if you ever pull out a GCF of a -1, all that does is flip your signs. So now we have this. Is there anybody that goes away now?
Yes,
Yes.
x2.
Yeah, the family of x minus 2 goes away. And we have x plus 2 over -1. I can see this as an answer because it's technically not wrong, but probably what they're going to do for the real answer. So this is okay. But an even better answer is we're just going to take this -1 and move it to the top. So I can see -1 times x plus 2. Or I could also see our my math lab distributing the -1 through and calling that -x minus 2. I can see all three of these as answers. I think these two are your better answer. But don't get me wrong, this is valid as well. Any questions on number 3 and 4 over simplifying?
No.
All right. Usually when I hear silence, that means compliance. All right, number 5, simple evaluating. So we've got this function f of x equal to x plus 8 all over 2x minus 1. And we have these three cases, f of x equal to 6, f of 0, and f of -3. So what are they wanting us to do here?
You have to solve for each number.
What do
Solve
you
for
mean? What do you mean solve?
So like for the first one, how it says f parentheses 6, you would plug 6. That 6 is x, so you would plug 6 where the
Good.
x are.
Perfect. If that's your idea of solving, yes. We call that evaluating. It's just plug and chug. Do what Jimmy says, plug in our x value because that's what they're telling us. So if we plug in, what is 6 plus 8?
14.
Yeah. What is 2 times 6?
12,
12 minus 1.
11,
So the question is, does this fraction reduce? No. So there's our first answer. If your fraction reduces, they do want you to take care of that. All right, so again, we're gonna plug 0 in. And all you guys gotta do, tell me what the answer is.
8 over -1, and then you can
Which really just tells us that the answer is
-8.
-8, just like what we kind of did right up here. We just took that negative and we just moved it to the numerator. Or if you think of division, positive divided by negative is negative. And last but not least,
for the numerator,
5 over -7.
all right, there you go. Or what you could do, even better, is we just slide that negative out front. So -5/7. But there's nothing wrong with 5 over -7. You could also just call this -5 over 7. That is valid as well. All three of those are the same. Because remember, I've always told you guys that negatives can go out front, in the top, or in the bottom of fractions. All three of those valid answers. All right, there's number 5. Just a quick plug and chug. All right, number 6. So number 6 is simple. divide and simplify. But remember, we don't really divide. What do we do? There's no such thing
We
as
multiply,
division.
keep change, flip.
Yeah, keep change flip. KCF. Kentucky Chicken Fried. Keep change flip. So we're going to keep that first fraction. We're going to change from division to multiplication. And we're going to flip the second fraction. Keep change flip. Okay. So we can do one of two things first. I'll let you all decide for us. We can do keep change flip and rewrite and then worry about factoring, or we could factor first and then do keep change flip. I'll let you be the call of that. What do you want to do?
Factor first.
Factor first. Let's do that. All right. So excuse me. We've got all these and they all factor. So go ahead. Start knocking out the factoring. Be careful of this one. The 3x squared minus 75. And many of these are pretty straightforward to factor. It's not like the 3x squared minus 8x minus 8 that we had earlier. I forgot an x squared on that. And when you know when one is factor, feel free to tell me the answer. We don't have to wait until all of them are factored.
The first numerator is x minus 5, x plus 3.
Yay.
And then the
Good.
second one is x plus 5, x plus 3.
Yay. Okay. I agree. I agree. I agree. I agree.
I think that for the bottom denominator, it is 3 outside, and then
Yes.
it's x, and then obviously the x on the other side. Then one is minus, one is positive, and then it's 5 and 5.
You got it. It is a difference of squares, but you got to pull the 3 out first. Because once you pull the 3 out, you get x squared minus 25. So once we pull that 3 out, that's what you end up with. And that will factor to the x minus 5, x plus 5. Perfect. Good job. Nice job of recognizing that GCF. Now, the only question is, what does x squared plus 10x plus 25 factor to?
I think that one's x plus 5, x plus 5.
Yeah, that's it. Alright, so now we're gonna do. Keep, change, flip. We're going to keep. Change. Flip, and I've already started it over here. So we're gonna keep the first fraction. So x minus 5, x plus 3. And the denominator is 3, x minus 5, x plus 5. Change division to multiplication. Flip. So we'll have x plus 5, x plus 5 in the numerator. Then we'll have x plus 3, x plus 5 in the denominator. And all we do now, cross off whoever's going away. So who's going away?
X plus 5.
Alright, so 1x plus 5 cancels 1x plus 5. Another x plus 5 cancels another x plus 5. So all the x plus 5s are now gone.
And then the next one is X plus 3.
So x plus 3 will cancel this numerator, x plus 3.
You can cancel the x minus 5.
Absolutely. X minus 5, x minus 5. So what's left?
3.
3. Alright, so let's talk about this. What's left in the numerator though?
Nothing.
Nothing, but there has to be a number here. And it can't be 0.
1.
1. Yeah, remember when you cancel everything out, either in the numerator or denominator, all that's left is the number 1. And then down here, as you said, all that we got left is this lowly little 3. So that big problem simplified down to one number, 1/3. Crazy. There we go. Any questions on 6? Cool. All right, let's jump to number 7. Well, they're doing great. Keep it up. Keep it up. So number 7, a little bit of adding and subtracting. So we got x squared minus 8x all over x minus 6 plus 12 all over x minus 6. So adding, subtracting is a lot like dealing with adding, subtracting of fractions. When we add and subtract fractions, what do we gotta have?
You have to have the same denominator.
Yeah, we gotta have common denominator. Do these have common denominators?
Yes.
Perfect. So we don't have to do anything really crazy there. Our common denominator is x minus 6. All we gotta do is combine across the numerator. Is there anybody getting together up here?
No.
But we don't just not write them down, so we just write it all down. So there's our numerator. And now we're right back to what we were just doing a couple of minutes ago when we did question 4 and 3. All we got to do is simplify. So what do we got to check first? What do we got to do first to simplify this?
First, see if there's any like terms that you could take out
Okay,
or anything that could be before factoring. What do you
okay,
s-
so like a GCF,
Yes.
any GCFs up here?
No.
We don't worry about the denominator because it's been factored since the beginning. All right, so then this, that's just up to factoring. And you, I believe you have actually just dealt with this a moment ago. Nope, just kidding. Something close to it.
X is gonna be X minus 6,
Okay,
X plus 2.
not a plus.
Why do I always do that? X minus 2.
Because a negative times a negative is a positive, and -6 and -2 is a -8. All right. So is there any canceling?
Yes,
Yes, who's going
X
away?
minus 6.
Boom. That family goes away. So all we're left with is X minus 2. And there we go. I believe number 8 will be another solving. Number 8 will be another, or not solving, but adding, subtracting. Let's take a look. Oh, and look at that. It was multiple choice. So X minus 2 was C. Even better was multiple choice. Look at that. That was great. I don't think we had, no, we didn't have any others. All right. So number 8, again, just as I predicted, another adding, subtracting, but that's okay. All right. Just getting this written down. So we got 2x all over 7x squared minus 50x plus 7. And we've got x squared minus 2x minus 35. And we want to add and subtract these things together. So in order to add and subtract these things together, what do we gotta do first? We didn't have to do it on the last one because it was already ready to go. What do we gotta do on this one?
The denominator have to be the same.
We gotta factor these. So that way we can figure out how to get our denominators the same. So these do factor. There's no GCF, I'll let you know that. It's just straight up AC, slide and divide, guess and check, box method, however you factor, you factor. Oh gosh, excuse me, yawn. When you know when something factors, just let me know.
With the bottom for 7x squared minus 50x plus
Mhm.
7, would that be 7x minus, I think minus 1, and then x minus 7?
You got it. Perfect. So there's the hard one. Nice job, Jada.
Thank you.
What about the next?
The next one, it could be x minus 7 and x plus 5.
You got it. There we go. All right. So we need to get these to have that common denominator. So we're going to look at that LCD. So what do you think the LCD for all this is going to be? And remember, my trick is write down the first denominator and then see if it works for the second one. So if we write down our first one, what am I going to write down?
Seven X plus one,
Not 7x plus 1.
I mean minus one,
And
X minus 7.
there we go, because that represents my first denominator. So these two match. Does this denominator match everything that's going on with the next denominator?
No,
What's missing?
5 plus X.
Yep. So just tack on the x plus 5, because if you look, there's the first denominator. See, it matches. There's the second denominator. Your LCD must match all denominators. So now it does. Okay. So what we need before we can combine them is we need to see what our fractions look like once they have that common denominator. So remember, we need to come up here and we need to multiply the numerator by whatever's missing down here. So here's my current denominator, the 7x minus 1, x minus 7. Here's the denominator, the LCD we just agreed upon. Here's what I have currently. Here's what I need. What's missing?
You have the X plus 5.
Okay, so this guy right here is gonna get multiplied top and bottom by x plus 5, x plus 5. So we actually do need to multiply these two out. So what's 2x times x?
2X squared,
Perfect. And then what is 2x times 5?
10X.
Okay. So there's our new numerator for the first fraction. So here's my second denominator, x minus 7, x plus 5. Here's the LCD that we agreed upon. What's missing between these two?
7x minus 1.
So again, we're gonna multiply this guy by 7x minus 1. 7x minus 1. So what is 3 times 7x?
21x.
And what is 3 times -1?
-3.
Yes. And now we're ready to do like what we did on number 7, where we add and subtract across the numerator. So let's combine like terms. Is anybody getting together with the 2x squared?
No.
No. So we write it down. Is anybody getting together with the 10x?
No.
Yes. Look over there.
Yes, 21x.
Yeah, these two should get together. They're both x's. So what is 10x and 21x?
31x.
Yay. And is anybody getting together with a -3?
No.
Nope. So the last thing we should do now is see if this factors. But if you think about it, there's no way this is gonna factor because 2 times 3 is 6. There's no way factors of 6 are gonna get me to 31. So this is actually the final answer because the numerator does not factor. Does that make sense?
Yes.
So we combined everything, we got our numerator, and that since this doesn't factor, there's not gonna be any canceling like what we had on number 7, where the numerator did factor. We just can't do it here. It's not gonna happen. This is unfactorable. All right, number 8. I think if there's a problem that trips people up the most on this exam, number 8 is the one that trips people up the most because you gotta factor, find that LCD, create your new fractions, and then put it all together. Usually this is the one that trips people up. So just be careful of number 8. And I don't know why I rewrote number 8 again. We're on number 9. Silly Mr. Armstrong. Number 9. Your factoring skills for everybody on here is great. Keep those skills up. Must have had a good teacher or something. Okay, so we want to simplify the complex fraction. But that's not too bad. We can do that. Remember, in order to simplify the complex fraction, when we were, if you have me, I kind of talked about Oprah. You're going to play Oprah. And in order to simplify the complex fraction, we're going to do what we call clear the fraction. We're going to get rid of all these denominators, and there's only 2. But before we can do this, before we can find the LCD, what do we got to do first? Just like what we did on number 8, before we could find that LCD, we had to do something first. What is it? Come on, what we got to do?
I want to factor that bottom
got-
part.
That's right. No, that's exactly right. We've got to factor before we can find the LCD. So what does this bottom part factor to?
X minus 9, x plus 9.
Yay. Yeah, we got to do that first. Okay, so now we can find the LCD. So again, I've got a denominator that's X. And then I've got a denominator that's X minus 9, X plus 9. So what's the LCD gonna be?
X minus 9, X, then X minus 9 and X plus 9.
That's right. It's gotta be made up of all of them. Good job. I love it. Yeah. It's gotta be made up of both of these. Because if I cover up, hey, look, there's my first denominator. It's right there. And if I cover up the X, there's the second denominator right there. See, this LCD shows both denominators. So now, like I said, we play Oprah. You're gonna get multiplied by X, X minus 9, X plus 9. And you're gonna get multiplied by X, X minus 9, X plus 9. And you're gonna get multiplied by X, X minus 9, X plus 9. Everyone gets multiplied by X, X minus 9, X plus 9. Okay. So what's gonna happen between my multiplication of my LCD and this X? What's gonna happen between those two things?
You're multiplying it by X minus 9 and X plus 9.
So what's gonna happen between the LCD and this X? Remember, what is the method we're doing here? What are we trying to do?
Get a common LCD.
Well, we got that, but we're trying to clear the what? Clear, what? What is that called? Clear the, I think it was an F word? Not a bad word.
The new
Clear the, what are we trying to do? Why are we multiplying everybody by this LCD again? It's called clear the what? Clear the. We've done this before, I think. It's an F word. What is that F word? Clear the
fraction.
fractions. So we're getting rid of the denominators. So what's gonna happen here is these X's cancel out. So what I have left here is 4 times X minus 9, X plus 9. Plus, is anything gonna cancel out over here?
No.
No, because there's no denominator. So 9 times X, I will just multiply that. That's 9X. And then we got X minus 9, X plus 9, right? Yes, Mr. Armstrong.
Yes.
So there's our new numerator. See, no more fractions. And then in the denominator, what's gonna happen between these two? The denominator of X minus 9, X plus 9 in the LCD, what's gonna happen? Anything canceling?
I'm sorry, I thought I was unmuted. X minus 9 and X plus 9 minus each other out.
Yep. The X minus 9s take each other out. The X plus 9s take each other out. So there's no more denominator. And you just got 16 times X, which is 16X. There we go. We just got to clean up the numerator now. Okay. So I'm going to go ahead and multiply these two first because it will make multiplying by the 4 easier. And the same thing over here. What is X minus 9 times X plus 9? So you got to do some FOIL here real quick. What is X minus 9 times X plus 9? So what do I get when I FOIL this?
X
Say it again.
squared.
X squared
Plus 9x.
Well, there will be a plus 9x. Okay, I'm gonna put a little side work over here since we're gonna go the full route. So we got an x squared plus a 9x. So that was the first. This is the outer that got us the 9x. What's the inner?
9x.
Minus 9x because it's negative. And then what's the last?
81.
Negative 81.
Negative.
What's gonna happen to these two middle pieces?
They cancel. That was simple, Shanice. They cancel each other out.
Right? So
That's
when I multiply those, I get x squared minus 81.
Mhm.
And that's gonna be the same thing over here. So now all I have to do is take the 4 through that parenthesis and take the 9x through this parenthesis, not as much multiplying. So what's 4 times x squared?
4x squared.
And what is 4 times a negative 81?
Negative 3.
Negative woo-woo.
Sorry. Negative 324. 324.
Okay. So there's our first guy. Now all we gotta do is take 9x times x squared.
And that'll be 9x cubed.
Perfect. Okay. And then what is 9x times negative 81?
Negative 729. 729.
729 with an X. And so now, I didn't want to have to go on to another page, but I will. If we do a quick little rearranging here, the 9x cubed comes first. Then it will be the 4x squared. And then we will have the negative 729x. And then we will have the minus 324. And all that is over 16x. So all I did was just put this in standard form from the highest power on down. Now the question is, does that reduce? Okay. Or not reduce, but does this numerator factor? So we have 4 terms. How do you factor 4 terms? I feel like this is a typo. But we'll go with it anyway, because this is a lot of work for that. And none of these answers match what's gonna happen. I wonder if this was supposed to be 16 over x squared. I bet you that's what it was. This is supposed to be 16 over x squared and then a minus 81 out to the side.
That makes
I bet you that was it.
because the two x will cancel, the x's will cancel each other out, and then you can divide.
Yeah. It's a typo, but let's go ahead and finish it the way it is. Let me do a quick grouping here. Yeah, that's it. There's a typo in that, and that's all right. Let me do grouping just to check this out. It's like, this thing just got really crazy on me. So remember grouping. You group the first two, you group the last two. So in here, we'll pull out an x squared. And that will leave us with 9x plus 4. And then in here, I know I'm going to pull out a negative, but the question is 729 divided by 9. So this is really yeah. In here, both of these are divisible by 81. So that will give us 9x plus 4. So it is GCFable. And it does factor to this part. But this guy also continues to factor. Because this is a difference of squares. So this numerator does factor. If you perform grouping on it, you'll end up with x squared minus 81 times 9x plus 4 all over 16x. And then because this is a difference of squares, it continues to factor to x minus 9, x plus 9, all over 9x plus 4, or times 9x plus 4, not all over. And then you got 16x. Does anything cancel? No. So that's actually the final answer, but it doesn't match any of our answers because there was a little typo, and that's all right. There was a little typo on it, but that's all right. We were able to do it. You guys did great. Just know that the one on the exam will not be as crazy as this. I promise that. Because the original problem should have looked like this. Let me show you. So let me get it written down real quick. Our original problem should have looked like that. Because our LCD should have really been just x squared. Yeah, that's what was happening.
I like that one.
Yeah, this is what the problem will look like more like on the exam. And this is much easier to work with. But no worries. We survived. You guys did great. Some good factoring, some good thinking. All right, enough on that problem. So number 9 done. Although this doesn't match any one of those answers, but that's okay. We got it simplified as best we can. All right, number 10, we're getting into solving. So once we get down here to number 13, this is the end of rationals. So 1 through 13 is all about rationals. Once you hit 14 through 20, that is radicals. So here at number 10, we've got 8 over x plus 1 over 3 equal to 7x. We're going to solve. So remember, when you solve rationals, it's just like what we did on number 9, where we simplified, although it's not going to be as crazy as number 9, I promise, where we simplified complex fractions. We want to find the LCD and we want to play Oprah and clear the fractions. So what's going to be the LCD here? Well, we've got a denominator of 3 and we got a denominator of x. What's our LCD?
3x.
Perfect. So everyone's gonna get a 3x. You get a 3x, you get a 3x, and you get a 3x. Everyone gets a 3x. So what's gonna happen between the 3x and the x?
It cancels. And so it'd be 3 times 8.
Yay. And what is 3 times 8?
$24. I'm sorry, Mr. Armstrong. Every time I think I'm muted or unmuted, I'm muted.
It's okay. That's why I've got patience and wait time. All right, what's gonna happen between the 3x and the 3? And anybody can answer these. Doesn't just have to be Shanice. So what's 3x time? What's gonna happen between the 3x and the 3?
The 3's cancel each other out. So it'd be
Ah.
x times 1,
Which is
1x.
1x or just x, however you wanna write it. What's gonna happen between the x and the 3x?
The x cancel out.
So we just got 7 times 3, which is
21.
21. So all we gotta do now is solve. Look how easy that is. What are we gonna do to solve?
To get x by itself,
How do we solve?
minus 24 on both sides. Negative, yeah, subtract 24.
Equals 21 minus
Negative,
24.
negative 3.
Perfect. And again, with these, because in module 3, it was really important that you check your answers. So we got to take this answer, we got to plug it back into what our denominators were. So remember the check. We had 8 over x plus 1 over 3 equal to 7 over x. And the check is really to make sure that none of these denominators are 0. Because if our denominator is 0, we have to throw this answer out. So if I put a -3 in here, is that 0?
That would be 0.
No. 8 over -3, is that 0?
Oh, no.
No. If I put a -3 in for this x, will that give me 0?
No.
And no, it won't. It'll just give me 7 over -3. So since these are not 0, this answer is a-okay.
You know how I always mess up because I want to subtract, like I want to solve the bottom part.
Yeah,
That's where I was. Okay.
but there's no solving there. So
Just-
here you plug it in and these are not 0, so we're okay. So when you come back in here, you'll actually check the A box and you'll put in -3. If we had to throw that answer out, then we would have checked no solution. But that answer was a-okay. Number 11 is the same. We got 1 over x minus x over 64 equal to 0. Okay. So all we got to do now, find that LCD, play Oprah. Our denominators currently are x and 64. So what we're going to do?
So times everything by 64x.
Yeah, there's our LCD. All right, our LCD is 64x. So you get 64x and you get a 64x and you get a 64x. All right, so let's see what happens. What's going to happen between the 64x and the x?
The x cancel each other out. So it'd be 1 times 64.
which is,
64.
okay, minus, what's gonna happen between the 64x and the 64?
They cancel each other out.
Gone, gone. So that's just x times x, which is,
X squared.
okay, equal to 0. Now, we don't like our x squareds to be negative. So how can I fix that real quick? What can turn a negative back into a positive? And we did this earlier.
Times it by 1. Negative
Not
1,
just-
sorry.
Yeah, times this by a -1. Because a -1 changes the signs. Or in other words, what we did was pull out a GCF of a -1. And now what are we gonna do with this?
Factor.
We can factor it because it's a difference of squares. What is this factor to?
X minus 8 and X plus 8.
Perfect. Perfect. So now we're gonna take our rule that we had, and we're gonna set each one of these factors to 0. Because this is like A times B times C equal to 0. So 1 is equal to 0. X minus 8 is equal to 0. X plus 8 is equal to 0. Does this make any sense? -1 equal to 0. Can I solve that?
No.
No, so this is just nonsense. Throw it out. -1 equal to 0. That doesn't make any sense. What do we get here when we solve for x?
X equal 8.
Yeah, because you just add 8. Add 8. What do we get here?
X equal -8.
That's right, because you just subtract 8, subtract 8. And now we got to do a quick check. But we have 2 answers to check this time. So remember, our original problem, 1 over x minus x over 64 equal to 0. So if I take a positive 8 and put it right in here for x, is that 0?
No.
No. So my positive 8 was a good answer. If I take -8 and plug it right in here for x, is that going to give me 0?
No.
So then this answer is good. So you have 2 answers that you'll put out here. -8, comma, +8. And there's number 11. Almost done with the rationals, I promise. The rationals are I think on this, those questions 1 through 13 are the ones that are gonna take you the most amount of time. Writing down the next problem. So we are going to be solving for W. Going to be solving for W. So we want W by itself. All right. So if you watched my videos or are part of my class, I've warned you about this problem. I said that it was coming and that there are, if I remember right, it's 4 steps to get through this. What's the first step? What are we going to do? And this is a lot like what we did on 11 and 10.
You have to have a common LCD.
Yeah, we need the LCD. You got it. So our denominators are W, M, and P. So what's the LCD?
WMP.
You got it. So just like before, we're going to multiply everybody by the LCD. WMP, you get a WMP, and you get a WMP. So let's write down what we have left. What's going to happen between the WMP and W?
The W's cross out, so it'd be MP times 1,
Which is just
MP.
equals what's going to happen between WMP and the M.
The M's cross out, which would
And
be
what do we got left?
WP
Okay. Plus what's going to happen
plus
between the P and the WMP?
the P's cross out, so it'll leave you with WM.
All right. So step 2 is to get your variable all on one side. And you either add or subtract. Well, the cool thing is we don't have to worry about this step because the W, which is what I want, is already on one side. But sometimes you might have to add or subtract to the other side to get them all on one side. So this is good. So step 2, already done. We don't have to do step 2. All right, step 3. This is the GCF start or part, not start. Because what do you notice both of these terms have?
W.
W. So we're going to pull that W out and you're going to tell me what you have left.
PM
P,
plus M, sorry, P plus
yeah, P plus M. And then this is the last step. Like I said, there's 4 steps. Step 1, LCD. Step 2, get the variable all on one side. Step 3, GCF. Step 4,
you divide MP to both sides to get rid of the MP.
you got it. Divide by the parenthesis. So MP equals W parenthesis P plus M. I'm going to divide both sides by P plus M. And now we know what W equals. MP all over P plus M. Oh, you couldn't see that part. When we divide by that parenthesis, it cancels these pieces out, leaving you with W. And then there's the answer. Any questions about number 12? It's 4 steps. Again, start with the LCD. Get the variable on one side. We didn't have to worry about that because it already happened. But if we did, we would just add or subtract. You pull the GCF out. And then you do some division. Okay. 13, our last rational problem. So in this one, it says Matty Evans drove 120 miles in the same amount of time it took a turbo propeller plane to travel 460 miles. The speed of the plane was 170 miles per hour faster than the speed of the car. Find the speed of the plane. Okay, so I need to write down a couple things. So Matty Evans was in a car and they drove a distance of a car 120 miles. We've got a plane that flew a distance 460 miles. We do not know the speed of the car. So let's call that X. But we do know the speed of the plane was 170 miles faster than the car. So being 170 miles faster than the car, you take X plus 170. So these are in miles per hour. Miles per hour. So this is what we know. Does that make sense? Car drove 120 miles. The plane drove 460 miles. The plane is 170 miles faster than the car. We just let the X be the car speed. Everyone good?
Yes.
All I did was write down what I knew. Now, here's the thing that's important for us. Both of these transportations did this in the same amount of time. Okay? That's the key here. So I want you to remember back, hopefully, somewhat, when you were in high school, you learned about a formula that says distance equals rate times time. Hold on 1 second. So again, the key is that they did it in the same amount of time, right? Let's get T by itself. How do I get rid of multiplication here? How do I get this guy by itself? How do I get rid of multiplication?
Why am I drawing a blank? You would divide?
Divide, yeah. So we're going to divide by R, divide by R. Notice that the time is equal to the distance over the R. The rate, or in other words, that R means speed. Let me just write this out here. D means distance. R means the rate, AKA speed. T means time. So both of these guys did it in the same amount of time, right? That's the key right here. Probably shouldn't have put a box around it. So that means that the distance divided by the rate of the car should equal the same distance divided by the rate of the plane, because both of them had the same time. You follow me on that logic?
Yes.
Because distance divided by rate equals time. And both of these were supposed to be the same. Therefore, what's the distance of the car? How far did the car go?
120 miles.
Okay. What's the speed of the car?
That one is X.
And that's going to equal What's the distance the plane went?
460 miles.
And what's the speed of the plane?
107
X.
x plus 170.
Okay. All we gotta do now is solve. And you can do this a couple of ways. You can take and do like what we did before, where we solved rationals, and you can find the LCD between these two. Find that LCD and then multiply everybody by it, like Oprah. Or this is just a proportion. How do we solve proportions? Cross multiply. So what is X times 460?
460x.
Yep. Equals. Now we're going to take 120 times all of this. So what's 120 times X?
120x.
So good. And then what is 120 times 170?
20,400.
All right. All we got to do now is keep solving for X. So how do I get X by itself?
Divide 120.
No division yet.
Sorry, minus 120x on both sides.
Good. So 460 minus 120. 340. X equal to the 20,400. Now what?
Now you divide 340. No, I thought my computer went out. Sorry. Then you divide 340 by both sides.
Okay. So X is equal to
Sorry, I was trying to find.
you're fine.
100.
Anyone can answer too. All you're doing is dividing two numbers.
660.
60. So this is how fast the car is going. We want the plane. How do I figure out the speed of the plane? How do we figure out the speed of the plane?
You would plug in your answer. 60 plus 170.
Good job. So X plus 170 equals what? Or 60 plus 170.
Equals 230.
Miles per hour. And that is the plane. And that's what we were after. That's what we were after. Any questions over rationals? So question 1 through 13, that was all about rationals. All about rationals. All right, now we jump into the radicals, and I promise the radicals will be much faster. They will be much faster. So right here, this first one, we want the cube root of negative 729. My advice to you, go to the calculator and see if it works. Just go to your calculator, type in cube root negative 729 and see what it gives you.
You can't do that. It's gonna be error.
It
It
gives me
is?
negative, it gives me -9.
My calculator says -9. Why did you think it would give you an error? Let's just talk about that real quick.
I don't know. My calculator would give me error. Like when I do like what's it called? Like radicals are negative.
Okay, but you got to be careful. So there are two kinds of radicals that we really deal with. We deal with the even root radicals and we deal with the odd root radicals. And with negative numbers, these each do different things. If you have an even root radical, let me adjust this, see if it'll zoom in a little bit better. Somewhat better. If you have an even root radical and a negative number, this is where the calculator will give you an error and say it does not exist. But if we're dealing with an odd root, which 3 is odd, the negative pops out. And then you just deal with the cube root of the number. So the negative is here because the negative pops out. And the cube root of 729 is actually 9. This is why I'm saying go to your calculator, let it do its job, double check yourself. Because there are two different ways that we deal with negative numbers under a root. If it's even, we're going to say does not exist. But if it's odd, we can work with that. So be careful. So the answer is actually -9. All right, number 15. So this one, 65,354. We want to turn this into scientific notation, and you will use the multiplication symbol. So how do I turn this into scientific notation? Because remember, scientific notation looks like a number times 10 to a power. And remember that this number has to be between 1 and 10.
So you have to keep moving your decimal to the left.
Okay. Good. My decimal is right here. You got to figure out where your decimal's at. And so we got to move this decimal to the left until we get that number between 1 and 10. Okay. So am I between 1 and 10?
No,
Now?
no,
Now?
no,
Now?
yes,
So we've got 6.5354 times 10 to the what?
-1, 2, 3, 4.
It is not negative.
Oh, to the right is negative, left is positive.
So it's a positive 4. And there we go. So whenever you move left, P is positive, the power, positive. Whenever you move right, your P is negative. Positive numbers mean really large numbers, like 65,000 is a large number. Negative powers mean really small numbers, less than 0 or less than 1. Okay, there we go. 16. 16 again, I would just go to my calculator and type this in and let it kick out an answer. So I would just go to my calculator, type it in, So like number 14, I would use my calculator. Number 16, I'm just gonna use my calculator.
The answer would be 18.
It would. Let me double check. I did not get 18.
Negative 27 times negative 2/3.
You're not multiplying those. That's a power. It's negative
Ah.
27 to the power of negative 2/3.
That's why. One moment.
No worries. I would use my calculator on this. And it's gonna want a fraction, no decimals. So don't put a decimal answer. If this thing comes out to a decimal, then turn it into a fraction. While you're working on that, I'm gonna pull up a calculator just to remind you of where these things are at. No, even pull up a decimals. Do that too. Do both of them. Decimals. Oh. What'd you guys get for an answer?
I'm getting an error, but that's because I'm using it
Okay.
wrong.
So when you're in Desmos, let's talk, you're gonna put a parenthesis, put your negative 27, close your parenthesis. To get your power on there, just hit this AB part. See how it kind of raised a little bit?
Ah,
So you hit your AB part, then you're gonna put in negative 2 divided by 3. There it is. But notice this is a decimal. So if you come right over here, see there's a little thing that looks like a fraction. If you click that, boom, there's the answer. So again, just let the calculator do the work. The answer is 1/9. If you were in the TI, well, let's get rid of that. That's no fun. Again, parenthesis, hit your negative 27, close the parenthesis. Here's our power button. And then put in negative alpha y equals for the fraction 2/3. Enter. There's the decimal. Hit alpha y equals. Go down to number 4. Enter, enter. There's the fraction. Okay. And just like before, how I said on that number 14, use your calculator. So if I go to Decimos, bring up my calculator, if I hit functions and go to miscellaneous, right here is so that I can do cube roots. So I hit that guy. Oops, I don't want to do that yet. Let's go down to a new one. So functions right there. So cube root negative 729. There's the answer. Or if I'm on my TI-84, hit math, go down to number 4 and push negative 729. Enter. There they are. Let the calculator help you out. 17. We're almost done. All right. Oh, come on. Pushing it too many times. There we go. So number 17 says rationalize. Rationalize. What does rationalizing mean? What are we gonna do? How do we rationalize? What's that? How do we rationalize?
I just did this.
You did.
Yeah. Oh my goodness. Where's my number?
Remember, we rationalize because some Joe Schmo long ago said we do not like radicals in the denominator. So to satisfy Joe Schmo, we have to rationalize. What does that mean? How do I get this radical out of the denominator? We're gonna have to multiply. We multiply top and bottom. What do we multiply top and bottom by?
Is it by the radical 7?
Yeah, normally it would be the radical 7, but because we have addition and subtraction down here, you have to multiply by the conjugate. Whenever you have addition and subtraction in the denominator with the radical, you use conjugates. But if it was just the radical 7, then absolutely, Chamise, we would multiply top and bottom by the radical 7. But what is a conjugate? Whenever I have A minus B, what's the conjugate of that going to be?
Ah, it's the opposite. So it's B.
It is the opposite, but it's not the opposite of the variables. It's the opposite of,
A plus B.
yes, you change the
That's
operation,
it. Okay.
conjugate. And vice versa, if I had A plus B, the conjugate would be A minus B. So we're gonna multiply top and bottom here by the conjugate. And remember that multiplying by conjugates is easy. We just perform the Florida in the denominator. We don't have to do full FOIL. We can just do the Florida, where we multiply the first and the last. So what is 2 times 2? Anybody? 2 times 2?
2 times 2 is 4.
Uh-huh. A positive or negative and a positive when multiplied, give me what?
Negative.
Perfect. And what's a square root of 7 times the square root of 7? What's that gonna give us?
Just 7.
Just 7, because remember, when you take two radicals and multiply them together and they are the same, all that happens is the number underneath pops out. That's why we multiply by the same radical. So what is 4 minus 7?
-3.
Perfect. So there's our denominator. Now all we got to do is just distribute across the top. What is 6 times 2?
12.
Good. What is 6 times the square root of 7?
Would that just be 6 times the square root of 7?
You got it, because they don't like each other. This is a number, this is a radical. but we don't just not write it down. We just put them next to each other. It's like a 6 times an X, it's just 6X. Okay. So here is what we have. Now your last step. Is there a number that will divide all three of these? The 12, the 6, and the 3.
3.
Yeah, the 3 will, right? So let's go ahead and actually just do the division. What is 12 divided by a -3?
4.
A -4, because a positive divided by a negative is negative. What is 6 divided by a -3?
-2.
Yay. And there's our answer. It is now rationalized. Any questions about rationalizing? All right, we're almost done. We're almost there, promise. 18, we're gonna do a little bit of solving. 18, we're gonna do a little bit of solving. Then we got a little bit of a one little word problem, and this is Pythagorean theorem, so that's not too bad. And then a little bit of complex. And we're done. All right, so we got the cube root of 2x minus 2 minus 6 equals -8. Okay, I'm gonna get rid of my little calculators here, because I don't really need them. Goodbye, Desmos. What else do I have? No, we don't need that either. So I just want to clean up to make my computer run a little bit faster. Okay. So how do we solve this? How do we get x by itself? What are we going to do?
First, you would add 6 to both sides.
You got it. Let's do that. Add 6, add 6. Cube root of 2x minus 2 equals -8 and a +6, -2. Now what are we going to do? How do we get rid of this cube root?
You cube both sides.
Yeah, to get rid of the cube root, we're going to cube it. So the cube and the cube root go away. 2x minus 2. And what is -2 cubed?
8.
It's actually going to be a -8. Because anytime you have a negative number squared, or to an even power, I should say. Let's review this. This is always important. Anytime you have a negative number to an even power, the answer is always a positive answer. But anytime you have a negative to an odd power, that's going to be a negative answer always. Okay? So it is a -8. All right, now what are we going to do to get x by itself?
Subtract 2 from both sides.
Not subtract 2.
Add
Already
I'm sorry, add 2.
add 2. There we go. So 2x is equal to, what's -8 plus 2?
-6.
And now what are we going to do?
Divide by 2.
X is equal to,
-3.
and just like before, because this is, dealing with roots, we need to check. Okay? We got to make sure that we can still perform the root. So we need to plug in, and this is going to be a full check. We need to make sure that this side does indeed equal a -8. So what's 2 times -3? Oh, and this is a cube root. So what is 2 times a negative 3?
-6.
Mm-hmm. What's a -6 minus 2?
-8. -8.
Yeah, you got it. Perfect. What's the cube root of -8? Let your calculator check that. What is that?
I think I did this backwards. -2. I did.
Yeah, it is.
Oh,
No, it's a -2. So does a -2 and a -6 give us a -8?
Yes.
yes.
Checks out. So this answer is A-OK. So we come in here and we'll put -3 and select A. All right, number 19. This is a Pythagorean theorem problem. So it says a spotlight is mounted on the eaves of a house 35 feet above the ground. A flower bed runs between the house and the sidewalk. So the closest the ladder can be placed to the house is 12 feet. How long of a ladder is needed so that an electrician can reach the place where the light is mounted? Okay, so we want to find out how long is the ladder. This is a Pythagorean theorem. Draw the triangle and give it a shot, and I'll be right back.
I can't hear you, sir.
Sorry about that. I was on mute for a second. So I said, hopefully you drew your picture and we got some sort of spotlight on the eaves, which is like a corner. That's what the eaves are. So we got some sort of like spotlight here. Okay. And here's our house, a little door, a little window. And we got a flower bed down here. Okay, so there's a flower. I'll go ahead, put a little bunny in it. Tomorrow's Easter. And another little flower. Yay, there's my picture. And we got some sort of sidewalk. And there's a ladder. How high up is the spotlight? Well, remember it says that it is 35 feet above the ground. How far away is the ladder? It tells us that it is 12 feet away. We want to know how long the ladder is. Do you see the right triangle that's in here? If you don't, I'll redraw it. That's the spotlight. That's the flower bed. That's what we're looking for. What is the Pythagorean theorem? What's the formula? What is our Pythagorean theorem formula? Come on, do you guys know the Pythagorean theorem? It says one of the formulas usually. Sorry, go on.
No, I'm sorry. Would it be, it would look as a fraction?
No, what is the Pythagorean theorem? Usually this is one of the formulas most everybody remembers from math. This one and y equals mx plus b.
Ah,
What is the Pythagorean theorem? Da, 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 da. Something, there's a relationship. For right triangles. What is it? What is the Pythagorean theorem? I think there were some variables.
A
in it.
squared plus B squared equals C squared.
There we go. There's our Pythagorean theorem. A squared plus B squared equals C squared. Remember I told you that there were 3 steps to doing
And then,
this. So our step 1, well, before we do step 1, how do we recognize the A and the B?
if I remember correctly, the 35 side, that side is A.
Okay,
Well, the bottom is B.
good. All right, so your A and B, remember these are called the legs. Sometimes we call this the leg squared plus the leg squared equals the hypotenuse squared. So the legs always form the right angle. So you said let 35 be A, let the 12 be B, that's fine. I could have let the 35 be B and the 12 be the A. It doesn't matter as long as you know that these are the legs. So who is the X then?
The X is C.
The X is C. That's the hypotenuse. The hypotenuse is always directly across from the right angle. The legs make the right angle. The hypotenuse is always across from the right angle. So step one, well, before we get to step one, let's plug in what we know. So there's what we know. So step one is to square the numbers. So what is 35 squared?
At that 1,225.
Okay. What is 12 squared?
144.
And that's equal to X squared. Second step. You need to is either add or subtract the numbers. So because our numbers are on the same side here, we're just going to add them. But if our two numbers were across from each other because of the equal sign, we would have subtracted them. So this step is either an add or subtract with the numbers. So because they're on the same side, we're just going to add them. So when I add them, I get 1,369 equal to X squared. The last step is you're going to square root both sides. Because how do I get rid of something squared? We square root it. And what do we end up getting for an answer? What is the square root of 1,369?
Is it a decimal answer?
I don't know. Did you try using your calculator?
I did, and I got, but I think I put it in wrong.
Make sure that you
So
do a square root,
square root.
not a cube root. It's a square root.
I got 36.6. Yeah, that's what I figured. 269. Square root.
I got 37.
It is 37. And that would be feet. Because everything is measured in feet. Yeah, it actually comes out to a nice, neat answer, 37. All right, any questions about number 17? Or sorry, not number 17, number 19. Just to put that in there.
Miss,
Yeah.
I'm sorry. Could you just show me how to use the calculator again?
So are you using the TI 84?
Yes.
So hit second X squared.
That's it.
and then type in 1369, hit enter.
I got it. Thank you.
Okay.
Second x squared.
Yep. Second x squared is the square root key. All right, last problem. We made it to the end. Yay. We did it. Yeah, we did it, as Dora the Explorer would say.
Yay!
So we have a quotient in complex form. We know this is complex because it's got I in it. And so they want us to simplify this answer. And they want your answer in the form of A plus BI. All right. So our answer must look like A plus BI. Okay. Just a couple of things to remind us. Remember, I really means that it is the square root of a -1. So whenever we take the square root of negative numbers now, we can handle this. Instead of saying this is does not equals DNE, we're going to take that negative and we're going to turn that negative into I and then deal with the square root. One other thing we also know, which is going to be important to us, what is I squared? What does that give us? So we're going to square a square root. What is that going to give us in the end?
It would give us 5 minus 8i.
No. Don't worry about that. Just right here.
okay.
What's I squared?
It
What does a square do to a square root?
make it a positive.
No, it just makes it go away.
Okay.
Squares and square roots cancel each other out. So I squared, you're left with -1.
Okay.
Because what's going on is you're taking a square root of -1 and we're going to square it. Squares take care of square roots. So that just leaves you with the inside. Fix this real quick. A little bit better. So you're squaring a square root, which cancels out, leaving you with the -1. Okay, now. Again, remember I is a square root, right? Do we like square roots in the denominator?
No.
No, thank you to Joe Schmo for not liking square roots in the denominator. So we are kind of going back to like what we did on number 17. And we're going to rationalize. So how am I going to get rid of the I in the denominator? How am I going to rationalize? What should I multiply the top and bottom by?
It would be 5 plus 8i.
You got it. Because remember, this is addition and subtraction with the radical. These are what we call complex conjugates. So if you have A plus BI, the complex conjugate would be A minus BI. And if I had A minus BI, the complex would be A plus BI. So we're going to use complex conjugates to help us out. And again, just like all the other complex, or just like all the other conjugates, we're just going to do the Florida. So we'll do the F and we'll do the L. What is 5 times 5?
25.
What's a negative times a positive?
Negative.
What is 8i times 8i?
64 I squared.
Okay. Now let's continue with this denominator. Hey, what do we know I squared is?
-1.
So this really looks like 25 minus 64 times a -1. So my denominator is really 25. What comes next?
Plus 64.
Perfect. And what is 25 plus 64?
89.
Okay. So there's our denominator now. Now let's deal with the numerator. So we do have the FOIL. So what's 8 times 5?
I'm sorry, Mr. Armstrong. Did you ask a question? Because my
Yeah,
internet went in and
it's
out.
okay. What's 8 times 5?
40.
Yeah. And then we'll do the outsides. What's 8 times 8i?
64I.
We'll do the inner. What's negative I times 5?
-5I.
And last but not least,
Negative.
what is, oh, okay, keep going.
Sorry. -8I squared.
Negative 8i squared. Okay. But again, we know what I squared is, right?
Yes, -1.
So this is really 40 plus 64i minus 5i minus 8 times a -1. What is 8 times a -1?
+8.
Okay. So all we got to do now is put like terms together. Who's getting together with the 40?
In the 64.
No.
Oh, no, sorry, 40 and the 8.
The 40 and the 8. These two get together, which gives us 48. And then do the two middle terms get together? The
Yes.
64i, yep. So what is 64i and a -5i?
Positive 59I.
Okay. So the last question is there a number that divides all three of these? That's the question. And I have no idea.
No.
I don't think there really is, but I just want to double check. Divided by. Just double checking some things real quick. Okay, yeah. So in order to get our answer in this form we want, we need to break this apart into its two fractions. There's one fraction here. And there's one fraction there. So we're just going to separate it into its two fractions. So the end answer is 48/89. This is what we call the A. Plus my second fraction is 59/89. That's the B. And then you put the I right beside it. And there we go. It is now in that form of A plus BI. And that's what they want.
Mr.
Oh,
Arm-
my gosh,
Yeah.
I see an error. Not 48/49, should be 89. Is that what you're gonna tell me, Chamise?
Yes, sir.
Yeah, there we go. Even better now. That would be an even better answer. They would like that one. And that, my friends, is the exam 3 review. Are there any questions, comments, or concerns over what you have seen?
Normally, like when I sign up for the exam, it tells you 2 sheets of paper, clean sheets of paper. Would they allow us to do 3?
Yeah, you can have more than one. So hold on, let me stop the recording.